So in last lecture we have covered about we have started with your third unit and we have covered the necessity of performing a short circuit analysis and at which stage of the power system network this short circuit analysis will be uh, processed we have seen. Okay, first we will be modeling a power system and that model power system will be undergoing a load flow analysis and followed by that load flow analysis it will there will be a short circuit analysis. Okay, so this is the step regarding the sequence regarding your power system network development and over here yesterday I have told you about the importance of short circuit analysis and we have discussed about the analysis that is the assumptions that you have to carry out before getting into a short circuit analysis. Okay, and today's agenda will be regarding your Z bus. Okay, Z bus building algorithm. So, as the name suggests, we will be studying about building your Z bus. Okay, we'll be dealing about how to build your Z bus. We will be seeing, and what is the necessity of building the Z bus. So there lies a question, and the answer for this it is that the answer for it lies in the previous lecture, that is why you have to add zbus means it is one of the assumption what we have carried out in previous lecture, and it was a primary assumption too. That is, if you are dealing with any kind of synchronous generator or any kind of PV bus, it is necessary to add reactance to it. Okay, and with respect to that, your Z bus building arises. Okay, you have to know where, if you are adding your Z bus, what is the correct and appropriate positioning of required to position your Z bus so that the short circuit analysis can be performed in a effective manner. Okay, that you have to know. For that, you have to know about formation of the Z bus matrix. Okay, so you know to form the Z bus matrix, right? That is, for example, if they have given any kind of admittance matrix, means you'll be taking the reciprocal. Okay, reciprocity will be taking, and you'll be taking the determinant value, and those calculations you'll be doing. Okay, that is, you'll be finding the inverse. To be short, you'll be finding the inverse. But now we are speaking about bus building algorithm. We are speaking about bus building algorithm. So that too with respect to your Z bus. So what uh, you have to understand is that forming a Z bus matrix is different from the bus building algorithm of the Z bus. Okay, formation of Z bus matrix is you can form through by using given values, but for the bus building algorithm, what happens? This is primarily and more specifically used for your short circuit analysis purpose. Okay, it is specifically used for your short circuit analysis purpose. So what happened is that you have to build a new bus. Okay, otherwise, in some cases, you can add the impedance value to an existing bus. So those are the criterions or the conditions that we'll be seeing. Okay, there lies nearly four criterion. Based upon the four criterion, how you will be building your Z bus. We'll be seeing. So that's the agenda of today's lecture. And in the well, taking the Y bus itself, I have told about your Z bus. Okay, how your Z bus is formed. So this Z bus, uh, okay, this Z bus voltage will be developed. Okay, this Z bus voltage developed between between nodes, any two nodes of the network. Okay, any two nodes of the network when a unit current source is applied. So this is what we have seen when you have covered your Y bus matrix. Okay. So your current source will be taking to it to be as a unit value. Okay. So this is basically your Ohm's law, V equal to I into Z. So this you will be considering to be 1, and then we'll be bringing it, we'll be finding out to be the Z bus. Okay. And similar to your self admittance matrix and what you can say. In your Y bus, what we'll be saying, self admittance matrix and transfer admittance, right? So for in your Y bus, okay, so your your diagonal elements will be called as self admittance, right? And with respect to your off diagonal element, it will be called as transfer admittance. Okay, it will be called as transfer admittance. Similar to that, your Y bus is, also has some particular specified name. Sorry, for your Z bus. So in the Z bus, you'll be calling it as your diagonal elements will be called as open circuit, driving point impedance. Okay, and for your off diagonal elements, be called as open circuit transfer impedance. Okay, so this is the analogy related to your Y bus and your Z bus. Okay, and followed by this, we'll be seeing about you have to know about two things. Okay, you have to know about what is tree and branch. So you might have learned in mathematics, and these two things you might have learned in mathematics, tree and branch. So if you want to know about this tree and branch, you can just refer the ebook what I have given. In the Murthy book, it is in the page number 8. You can just refer to it. For simplicity, you can take a tree is nothing but a circuit uh, from which connects any two nodes. So this will be contributing to your nodes. Okay, and from this there rises branches. Okay, so that is your power system network will be represented in the form of a graphical image. That mainly it will be similar to that of a graph theory. So all the buses will be represented with your nodes. Okay, all the transmission lines will be called as elements in as per your graph theory. Okay, you can just refer Murthy book and see through those things. Okay, now I'll be directly getting into your ZBus algorithm. Okay, what are the various methods or sub-criterions you have to consider while forming a Z bus? Okay, now I have told you why you have to form the Z bus. The primary part is to perform short circuit analysis. Okay, you have to add a separate impedance bus. Okay, otherwise in some cases you can add in the even the existing bus. Okay, for that you will be adding as Z bus. Okay, so the heading is Z bus formation. Z bus formation using bus building algorithm. Okay, so there exist nearly 4 cases. Okay, there exist nearly 4 cases in this algorithm. Okay, and here you can just consider we will be taking all your new bus will be taking it to be P. Okay, followed by the existing bus will be considering it to be as Q. Okay, so uh, based upon these two elements there is nearly conditions four conditions. Okay, so what are those 4 conditions we'll be saying? The first condition is adding a branch of impedance ZB from a new bus P to the reference bus. So here you'll be having 2 bus. Okay, here you will be having 2 bus, and one is your reference bus and another one is your new bus. So as per this criterion, what happens, you will be adding your Z bus or your impedance to in between your new bus value and the reference bus value. Okay, first I will be enlisting all the 4 criterias, and after that I will be getting into each one. At that time I will be drawing the diagram, so it will be easy for you. So the second one is adding a branch of impedance ZB from a new bus P to an existing bus Q. Okay, so this is the second criteria. So third one is adding a branch of impedance ZB from an existing bus Q from an existing bus Q to the reference bus. Okay, so this is your third criteria, and followed by this, we'll be moving to the fourth one, adding a branch of impedance ZB between existing buses. Okay, so these are the various criteria. Okay, first one is the branch will be inserted between your reference and the new bus P, and after that the branch will be, second is the branch be inserted between your new bus and an existing bus, and after that it is about between your existing bus and then the reference bus, then the final one is between your any two existing buses. Okay, so these are the four criteria, and based upon these four criteria, we will be formulating some formulas. Okay, we'll be formulating some formulas, and based upon those formulas only, we will be building your Z bus. Okay, using that Z bus, you can.
Instead of forming this much complexity, we can directly derive from the given diagram, no sir, load diagram, line flow diagram.
What you're saying directly?
Sir, if they give directly the line impedance, we can directly write the line impedance. So why we are deriving like this?
Yeah, actually, this is a part wherein they won't be giving the value of that impedance. That impedance value also, it is you who have to find it. You have to find it and you have to attach to it. That is, um, if it is coming between these two buses means what is the formula and what is the ZB value, you have to take it out. They won't be giving the values directly. Okay, it's just like analysis. So in the analysis part, you have to consider all the cases. Okay, while dealing with the problem only, you'll be understanding about this entire process. Okay, it is more or less similar to that Gauss Seidel only. As I said in the Gauss Seidel, while we are dealing with the problem only, you came to understand at least some 30 to 40%. Okay, so these algorithms and all are more specific, but when you're applying the problem only, you'll be able to understand. The same goes with this ZBus also. Okay, I'll be telling when dealing with the problems. When dealing with the problems, it is very, very simple. You have to consider only 4 steps. Within the 4 steps, you can easily solve the problem. Okay, so we'll be moving on with respect to the first one. So it is adding a branch of impedance ZB from a new bus references. Okay, and the diagram for this, it will be in this fashion. You can consider a n bus system. So this is a n bus system. Okay, you don't know the number of buses involved in this n bus system. And over here, this you can take it to be your reference point, reference bus. Okay, you can take it to be the reference bus. And followed by this, you can take this as a bus P, and this will be your ZB. So now this ZB is connected between your new bus P as well as your reference bus. Okay, so this is how the diagram looks like for your first criteria. Okay, and over here, what happens when you're connecting a new bus or the new ZB to your to this N bus system? Okay, so that's what we have to take into account. So over here, your Z bus new becomes, that is your Z bus matrix becomes. So here we'll be talking with respect to your matrix only. It will be your Z original. With respect to your Z original, the size of the matrix gets increases. Okay, because bus is added as an additive. Okay, as an extra, a bus is added. So it is default that the size of the matrix get increases, and over here this ZB value will be lying at this point, that is at the diagonal point at the end. Okay, at the end of the diagonal, it becomes the diagonal element. Okay, and
So you said there will be no impedance values will be given, no sir. Then how we are getting the Z original and ZB values also?
these values you are just asking, right?
Yes, sir.
Okay. These values, just a minute. Yeah, ZB value they will be giving. Okay, ZB value they will be giving. But what happens when it gets added to the what you can say, added to this bus? Okay, added to this N bus system. After adding to the N bus system, this Z bus new value is there, right? So this is what we'll be calculating. Okay, so that's what you asked, right? So they'll be giving Z bus ZB value directly. So then, what is the necessity of finding the Z bus matrix? That's what you asked, right, Karan?
Yes, sir. Yes, sir.
Okay. Right. So that's the thing. The particular point is that that's what I have started from the beginning. So as in the beginning, as I said, you have to yes, we have seen the assumption, right? So from the assumption, the first point is that you will be adding the reactance value. Okay, for your PV bus as well as the generator bus. Okay, so the ZB value will be given. Basically, it will be given. But after adding those ZB, how your N bus system varies. Okay, how this N bus system value changes, how this N bus system impedance value changes. So that's what this bus building algorithm is all about. Okay, it is primarily with respect to your short circuit analysis, but upon adding this ZB, how your system impedance changes. So that's what we'll be finding it out. Okay, and so this is a easy formula, that is you'll be adding directly to your reference bus. So since your reference bus it is added, these values over here and these values over here will be zeros. Okay, will be contributing to zeros. 0 0 followed by zeros. So if this is a 3x3 matrix, first if this, for example, I'm saying if this is a 3x3 matrix, means after this you will be adding the ZB. So this is a new bus. So what happens Upon adding, it becomes a 4 cross 4 matrix. At that period, you have to know about the new Z bus value. Okay, and for that only we'll be making use of this formula. I hope you might have got some idea. Might not be clear to you. Okay, and I'll be first enlisting all the formulas, and in afternoon class we'll be dealing with the problem, a small problem. Within 4 steps it gets over. Okay, so at that period you can easily understand it. So we'll be now moving to the second part. So the second part is adding ZB a new bus P to an existing bus Q. Okay, so this we'll be seeing now. So for this, the diagram goes like this. Again, you have to consider an N bus system. And for this, this we can consider to be your bus Q. So it is an existing system. And over here you can consider your bus P. Okay, so the ZB lies in between these two. Okay, so it is adding ZB to an existing system. So how your Z bus new matrix becomes is, so it becomes in this fashion. The same thing it goes with Z original okay. Now how the values becomes means this there exists your ZB, this ZB gets additive with your ZQQ. Okay, it is this element here, the ZQ will be there, right? So the last point of this element gets added with this your ZB, and then what happens is that you have to write the same value of your Z1Q over here, then Z2Q followed by your ZNQ. So if this is a 3 cross 3 matrix means, so what happens, you have to put this Z13 value over here. Okay, the same value gets repeated, and at this point again it is symmetrical. So here it becomes ZQ1 followed by ZQ2 and followed up to ZNQ. Okay, so this formula is also very simple. You have to make this additive point. Okay, and other things, this matrix values get just repeated. So this is a formula for your second criteria. Okay, and next you will be moving to the third criteria. And over here I'll be writing the points, you just see through it. So these points are the thing what I have already explained. So here the element of n plus 1th column. So we are speaking about column, that is this column. Okay, n plus 1th column or the elements of the elements of Gth column. Sorry, qth column. Okay, speaking with respect to q, so it is qth column. So these things. Okay. So followed by the next one is the element of n plus 1 throw. Okay, or the elements of q throw. Okay, so here the diagonal element is given by the sum of zqqq and zp. Okay, so this is what regarding this thing. Now we are moving to the third part. Third one is about addition of z bus, okay, from an existing bus q to the reference bus. And for this, the diagram goes like this. Again, you have to consider a n bus system. Okay, so over here, the existing bus also remains here. Okay, your reference bus is also remains here. So you have to connect these two with respect to a ZB. So in such a criterion, so what happens here? Z bus new. Okay, and for this we'll be making use of some formula. Okay, so the thing is that we'll be short circuiting your bus queue, and hence impedance matrix as modified by eliminating your n plus 1 column. So this gets reduced. Okay, the matrix gets reduced. So I'll be writing it out. So I had some network problem. Okay, So with this third one, we can just stop it out and we'll be moving. Okay, and so here we are just short circuiting it. Okay. We're short circuiting the bus Q, and hence the bus impedance matrix is modified by eliminating n plus 1th column and row. Okay, so the original matrix size gets reduced in this condition, and over here they'll be making use of a formula called Cron reduction rule. So if you want to know about this reduction rule, you can refer the book also. So you just try to know the formula alone. That's very important. Over here, Z J K actual, okay, will be equal to Z J K minus Z J n plus 1, okay, into Z n plus 1 into K. Okay, this entire part gets divided by Z n plus 1 followed by n plus 1. Okay, so this is what regarding your third criteria. So there's still another one criteria. So it is somewhat a bigger criteria, but it is a simple one only. So that will be dealing with in the next class. So for you, today's 6th hour will be handled by myself. That is at 3 o'clock. So at the 3 o'clock, we will be seeing another one criteria, and after that, we will be dealing with a small problem. So then it will be easy for you to understand. Okay. So okay. So with this, I think we can close the morning session. So we can just meet in the afternoon session. Thank you.